Okay, let's proceed further. Page 13. Now we have a question which states that if CP and CD are pair of conjugate semi-diameters of an ellipse with semi-axes of lengths A and B, prove that curvature at point P is CD cube by AB. We know that the extremities of a pair of conjugate diameters of an ellipse are given by P has A cos theta, B sin theta, and D minus A sin theta, B cos theta. Now let me first find the radius of curvature at point P. Now at point P, your x is A cos theta and y is B sin theta. Therefore, dx by d theta is minus A sin theta, dy by d theta is B cos theta, so that dy by dx is dy by d theta into d theta by dx, that is B cos theta into 1 by minus A sin theta, which is minus B by A cot theta. Okay, this is your y1. So your y1 is minus B by A cot theta. Now let me differentiate it with respect to x in order to find y2. y2 is minus b by a. Cot means minus cosecant square theta, and derivative of theta with respect to s d theta by dx. So this is minus minus plus b by a cosec square theta and d theta by dx. You have dx by d theta minus a sin theta, so it is 1 by minus a sin theta. So it is b by a square sin cube theta minus times. Therefore, the radius of curvature rho is equal 1 plus y1 square raised power 3 by 2 divided by y2. It is 1 plus b square by a square cos square theta by sin square theta raised power 3 by 2. You see, your y1 is minus b by a cot theta or minus b by a cos theta by sin theta. That is what we have used. And your y2 is minus b by a square sin cube theta. Now this can be written as a square sin square theta plus b square cos square theta whole raised power 3 by 2 divided by a square sin square theta raised power 3 by 2. This is the numerator, and denominator is a square sin cube theta by b. I have omitted minus sign because of the radius of curvature. It is taken as positive. So this is equal to a square sin square theta plus b square cos square theta raised power 3 by 2 divided by a cube sin cube theta. Because this is a sin theta whole square raised power 3 by 2, 2 and a half cancels out. This is a cube sin cube, and this is a square sin cube theta by b. Sin cube, a square and a square goes. This is a square sin square theta plus b square cos square theta raised power 3 by 2 divided by ab. So I have to prove that radius of curvature is equal to CD cube by AB. You know, the point D is minus A sin theta B cos theta, and this is the center C 0 0. So what is the distance? Distance formula CD square is under root or CD square is y2 minus y1 whole square. So a square sine square, b square cos square, or your CD square. We know your C is 0 0 and D is minus a sine theta b cos theta. This is 1. Therefore, CD square is equal to a square sine square theta by distance formula, b square cos square theta. Now a square sine square b square cos square is CD square. So let me use in 1. This is 2. Using 2 in 1, we will get radius of curvature rho is equal CD square whole raised power 3 by 2 divided by AB, which is nothing but CD cube by AB. Now there is one more part of this question. It says that if rho 1, again let me draw the shape of an ellipse. This is C0 0, this is P and this is D. If rho 1 is radius of curvature at point P and rho 2 is radius of curvature at point Q, then you have to show that rho 1 raised power 2 by 3 plus rho 2 raised power 2 by 3 is equal to a square plus b square by ab. This is quite easy. You see, this is your rho. Now, if rho 1 is radius of curvature at point P, then rho 1 will be a square sine square b square cos square 3 by 2 divided by ab. If rho 2 is the radius of curvature at point this, a sine theta minus a sine theta b cos theta, there is difference of pi by 2. So, rho 2 will be a square cos square plus b square sine square raised power 3 by divided by ab. You can raise power to the power 2 by 3. This is 3 by 2 and this is 2 by 3. 3 by 2 and 2 by 2, 2 by 2, 3 by 2 and 2 by 3 will cancel out. This will be rho 1 raised power 2 by 3. This will be a square b square ab raised power 2 by 3. Then at D, at point D, it will be a square cos square b square sine square by ab raised power 2 by 3. You will add the 2, you will get this. So this is an exercise which you will do of your own. Now let me take one more question. Question number 14. For question page number 14. It says that question is show that the radius of curvature at the point a cos cube theta, a sine cube theta to the curve x raised power 2 by 3 plus y raised power 2 by 3 equal to a raised power 2 by 3 is 3a sine theta cos theta. Means you have to prove that radius of curvature rho is equal to 3a sine theta cos theta for this curve at this point. You can see that if you will put x equal a cos cube theta and y equal a sine cube theta, this will always satisfy this equation. You will always get x raised power 2 by 3 plus y raised power 2 by 3 equal a raised power 2 by 3 because x is a cos cube raised power 2 by whole cube raised power 2 by 3. This will be, let me show this. The point a cos cube theta, a sine cube theta lies on the curve x raised power 2 by 3 plus y raised power 2 by 3 equal to a raised power 2 by 3 because x raised power 2 by 3 left hand side plus y raised power 2 by 3 is a cos cube theta raised power 2 by 3 plus a sine cube theta raised power 2 by 3. This is a raised power 2 by 3 cos square theta. a raised power 2 by 3 sine square theta, or this is a raised power 2 by 3 cos square theta plus sine square theta, which is nothing but a raised power 2 by 3, which is the right hand side. So the point lies on the curve. So we can find radius of curvature on this point only. So we have what we have, x is equal to a cos cube theta and y is equal to a sine cube theta. This is the point. This always satisfies this curve. So x is a cos cube theta, y is a sine cube theta, satisfies this curve. Therefore we have this. Now we have x and we have y. So let me differentiate with respect to x. I will get dx by d theta. It is minus 3a cos square theta sine theta. Dy by d theta. It is 3a sine square theta cos theta. Therefore, dy by dx is dy by d theta into d theta by dx. It is 3a sine square theta cos theta into 1 by minus 3a cos square theta sine theta. So dy by dx is 3a cancels out, sine goes, cos goes, so it is minus tan theta. This is your y1. Now let me differentiate again with respect to theta. I will get second order derivative dx to equal minus tan is sec square theta into d theta by dx. This is minus 1 by cos square theta and your d theta by dx. What is d theta by dx? This is dx by d theta. This is 1 by minus 3a cos square theta sine theta. So this is minus minus plus 1 by 3 a cos 4 theta sine theta. Okay, is it okay? Dx by d theta, dy by d theta. So d theta by dx, dx, d theta by dx is this. Okay, this is okay. Now rho is r square 1 plus y1 square raised power 3 by 2 divided by y2. This is 1 plus tan square 3 by 2 divided by y2. This is minus 3a cos 4 theta sine theta. Reciprocal of this. 1 plus tan square is sec square. Sec square theta raised power 3 by 2 into 3a. Let me omit this negative sign. 3a cos 4 theta sine theta. So this is secant cube, or 1 by cos cube theta 3a cos 4 theta sine theta. Cos cube and cos goes. This is 3a sine theta cos theta. This is the radius of curvature we were supposed to find, right? Now let me take up the polar form. Let r is equal to a times 1 minus cos theta, and let me find the radius of curvature rho. You know, for polar coordinates, rho is equal to r square plus r1 square raised power 3 by 2 divided by r square plus twice r1 square minus rr2. This article I have already proved. So this is r. Now let me differentiate with respect to theta. Dr by d theta, or r1, is a sine theta. R2 is a cos theta, and we need RR2. Therefore, R2 is a cos theta into a1 minus cos theta, which is a square cos theta minus cos square theta. Therefore, rho is r square a square 1 minus cos theta whole square. This is r square plus r1 square whole raised power 3 by 2 divided by r square plus twice r1 square minus rr2. This is your rr2. So minus a square cos theta minus cos square theta. So this is a square whole raised power 3 by 2. Now this is 1 minus cos the whole square. It is 1 square plus cos square theta minus 2 cos theta plus sine square theta. I have taken a square out. Divided by a square out. 1 minus cos the whole square is again 1 square plus cos square theta minus 2 cos theta plus 2 sine square theta minus cos theta minus minus plus cos square theta. Now this is a cube. You see this is 1 plus cos square plus sine square is again 1. 1 plus 1 is 2. 1 minus cos theta raised power 3 by 2. Sine square theta plus cos square theta is 1. 1 plus 1 is 2. 2 minus 2 cos theta is twice 1 minus cos theta raised power 3 by 2. Now the denominator is a square. This is 1 plus cos square plus cos square. It is 2 cos square plus 2 sine square. Twice cos square plus sine square is 2 into 1, which is 2. 2 plus 1 is 3. Then this is minus 2 cos theta and minus cos theta. So it's minus 3 cos theta. So you have a 2 raised power 3 by 2 1 minus cos theta raised power 3 by 2 divided by 3 times 1 minus cos theta. Or you may write it as a by 3 2 raised power 3 by 2 1 minus cos theta raised power 3 by 2 minus 1. This is 1 minus cos theta raised power 3 by 2. This is 1 minus cos theta raised power 1. So a by 3 2 raised power 3 by 2. Now 1 minus cos theta is twice sine square theta by 2 whole raised power 3 by 2 minus 1 is 1 by 2. Fine. Or you have a by 3 2 raised power 3 by 2 2 raised power 1 by 2 sine theta by 2. So this is 2 raised power 3 by 2 2 raised power 1 by 2. Bases are same. This is 3 by 2 plus 1 by 2. It is 3 raised power 4 by 2. 2 raised power 4 by 2. This is 2 raised power 2. So 4a by 3 sine theta by 2. This is the radius of curvature for this polar curve cardioid. Similarly, you can show that if r is a times 1 plus cos theta, instead of minus you have plus, then rho is equal to 4a by 3 cos theta by 2. We can do it. Home assignment. Home assignment. Let me take one more question. 16. Say you have r raised power n equal a raised power n cos n theta. You have to find rho. So you need to find r1, r2, rr2. Now let me differentiate with respect to theta. What we will get? N r raised power n minus 1 r1 is equal to minus n a raised power n sine n theta. A raised power is constant. This is cos n theta. So cos means minus sine n theta and n theta means n. So n and n goes. Your r1 is minus a raised power n sine n theta by r raised power n minus 1. Or you can write it as minus a raised power n sine n theta into r divided by r raised power n. R raised power n minus 1 can be written as r raised power n, and this minus r raised power minus 1 is r in the numerator. But your r raised power n, it is given that it is a raised power n cos n theta. So this is minus r a raised power n sine n theta divided by a raised power n cos n theta. So your r1 is minus r tan n theta. Now let me find r2. Differentiate with respect to theta. r2 is minus r as it is tan means n sec square n theta. Then r means r1 tan n theta. Now your r1 is minus r tan n theta. Let me substitute here r n sec square n theta. Then your r1 is minus r tan square n theta. Fine. Or this is minus r times n sec square n theta minus tan square n theta. Therefore, final term r2 is minus r square multiplied by r on both sides n sec square n theta minus tan square n theta. Now, rho r square plus r1 square raised power 3 by 2 r square plus twice r1 square minus r2. Let me find it out. This is r square as it is. Because r1 is also in terms of r, so I will not substitute r. Now r1 is, you see, your r1 is minus r tan and theta. So r1 square will be r square tan square. So plus r square tan square and theta whole raised power 3 by 2 divided by r square plus twice r1 square minus rr2. This is rr2 minus rr2 means minus minus plus r square n secant square n theta minus tan square n theta. Fine. We have nothing to do now. This is r square raised power 3 by 2. What remains inside is 1 plus tan square, which is secant square. Secant square n theta raised power 3 by 2. R square out, r square raised power 3 by 2. Then remains 1 plus tan square, which is sec square, divided by r square out everywhere. 1 plus 2 tan square n theta plus n sec square n theta minus tan square n theta. So this is r cube in the numerator, secant cube n theta, square and 1/2. Then r square, this is 1 plus 2 tan square minus tan square. So it is 1 plus tan square plus n sec square n theta. Or this is r secant cube n theta. Now 1 plus tan square is sec square n theta. Sec square n theta plus n sec square n theta. So it is 1 plus n. So this is r by 1 plus n secant n theta. This is it. You can put it like this. This is rho. Or if you want, you have rho equal r by 1 plus n Secant is 1 by cos n theta. But it is given from this question r is power n is a raised power n cos n theta. So cos n theta will be r is power n by a raised power n. So 1 plus n r is power n by a raised power n, because r is power n is a raised power n cos n theta. This is given. So finally what you have is that a raised power n 1 plus n 1 upon r raised power n minus 1. This is the radius of curvature. This is the radius of curvature, or your radius of curvature is a raised power n plus 1 1 by r raised power n minus 1. You can put it like this also. Actually, the question is that prove that for this curve the radius of curvature varies inversely as the n minus 1th power of the radius vector. N minus 1th power of the radius vector. This is n minus 1. This is constant of proportionality. We can write rho is proportional to 1 by n r raised power n minus 1. Thank you.